Now, guys, I'm still in the absolute value part. I did already in the preceding video two examples for the absolute value. One equal to a negative, and we said it's impossible. One equal to a constant like 6 that I know if it's positive or negative, and we solved it already. And now we will solve an absolute value equal to a polynomial that I'm not sure about itself. When I'm doing this case, you have two methods to do this. Either you need to put a condition and solve and check if the answer verify the condition, or you solve normally and when you finish, you check your answer. But I need to write the condition. This equation exists if what? Can an absolute value gives me a negative answer? No. Am I sure about the sum of minus x minus 5? No. So this equation exists if minus 2x minus 5 is bigger or equal than 0. It means minus 2x is bigger or equal than 5. It means x is less than or equal to minus 5 over 2. So if x is not less than or equal to minus 5 over 2, the answer, this one will be negative and the equation will have no solutions. Then I start to solve. As we did before, I have two cases. Either x plus 1 is equal minus 2x minus 5, either minus x plus 1 is equal minus 2x minus 5. And then I solve the first one here. I will have 3x is equal minus 6, x is equal minus 2. Is minus 2 less than minus 5 over 2? No, it's rejected. If you didn't do the condition, you will replace and check. Minus 2 plus 1 gives me absolute value of minus 1 gives me 1. The first part gonna give me 1 is equal. Minus 2 times minus 2, 4 minus 5, it gives me minus 1. Is it right? That's why it doesn't work. Let's do the second part. Minus x minus 1 is equal minus 2x minus 5. So x is equal minus 4. Let's see. Is it accepted? Is minus 4 less than minus 5 or 2? Yes. Let's say we didn't do the condition. I will replace. Minus 4 plus 1 minus 3. Absolute value gives me 3 is equal. Minus 2 times 4. It's 8. Times 4, it's 8. 8 minus 5, it's 3. So it's right. So this is my solution. Now, Now I can graph those and check if my answer is right. The blue represents the absolute value. This one is the absolute value of x plus 1. Can you see the vertex here? This is one particular point. This is another one. And this line represents the line. Let me go back just to check it. It's minus 2x minus 5. Oh no, not this one. Sorry, guys. Where am I? I lost it. It's here. This one represent y is equal minus 2x minus 5. How do we plot a line? You know how do we plot a line? X and y. I can take for x 0, it gives me y minus 5. Look at it. It's here. I can take for x, for example, minus 1. Y will be minus 3. So for x minus 1, y minus 3, and then I draw the line. Where did they meet? Did they meet at x equal minus 4? Yes, it means what I did before is right. You see, they didn't meet at the point x equal, what was the first answer? Minus 2. If I look, where is x minus 2? X equal minus 2 on the absolute value is here, on the line is here. It's not a point of intersection. Let's move now to another example. I can have absolute value equal to absolute value. Also, I have two methods. The first method, since the both parts are, I know that they are positive, so I can square both sides. So both are positive, I can square both sides. You square it and then you develop. I don't want to lose my time, so directly I did it already. And you will get this answer. It's a quadratic equation. It is 5x squared minus 36x. What was here? Plus or minus 7? I erased it. I don't remember. Let me check. Oh, plus. So just because I want to write better. Okay, now you know how to do this on the calculator or on Delta. And again, what you need to do, you got those two answers. You need to check if those two works. If I replace x by 1 over 5, both are equal. It's right. And if I replace x by 7, also both are equal, and that's right. Method 2, either you take it as it is both positive, so 3x minus 4 equal to x plus 3, you solve, and you'll get x equal to 7. Either one is equal to the opposite of the second one, because if you take the first equal to minus of the second, or the second equal to minus of the first, it's the same thing. So I just solve it once, and also I will get the same answer. Let's graph the two absolute values. I graph it on GeoGebra to finish quickly because already we saw how to graph an absolute value. When I graph it, the blue one here represents 3x minus 4, the purple 2x plus 3. Where do they meet? I can see the 2 points A and B. Let's look at the coordinate of A. Ax is equal to 0.2. This is 1 over 5. So here, because I got 1 over 5. And the second one here, B, 7. So this is x equals 7. And this one is x equal 1 over 5. And I can confirm that my work that I did is right from the graph. Now let's move to how do we solve absolute value inequalities. Also, I have some special case for absolute value inequalities. If I want to solve absolute value of x plus 1 bigger than minus 2, why it's all real number? As I'm saying, absolute value bigger than a negative number. But the absolute value is all the time positive. And the positive number is all the time bigger than a negative number. That's why it's all real numbers. How can I see this graphically? This is absolute value of x plus 1. And the red one is the line y equal minus 2. So what are the possible answers for that? Any x. All the real numbers. Look, bigger than, or so all the graph of the absolute value is above y equal minus 2, so I have all real number as a solution. But if I want to solve the same thing, absolute value of x plus 1 but less than minus 2, if I want to analyze it algebraically, this one is a positive answer. Can a positive answer be less than a negative answer? This is impossible. And if I want to see it graphically, I want the part it's less than minus 2. There is no part of the absolute value that's less than minus 2. That's why it is impossible. Now, this one, what I did in the beginning of the lesson when I was talking about a absolute value of a bigger than b less than b, so that's it. I have absolute value of 3 minus 2x bigger or equal than 1. This one gives me two inequalities. I didn't write anything here, or and, because all the time the students are confused. Should I write or? Should I write and? Don't write anything here, and in the end, write the final answer or and. So either it's as it is, either the expression inside is positive, so it will give me the same. Either the expression inside is negative, so it should give me the opposite of the inside. And then I solve. 3 minus 2x bigger than 1, minus 2x bigger or equal than 1 minus 3, minus 2x bigger or equal than minus 2. Then divide by negative, we switch the sign. X less than or equal to 1. And then the second part, I will get x bigger or equal than 2. Can I write this one x between or no? No, I cannot. X should be less than 1, or x should be bigger or equal to. I cannot write it like this. I cannot write it like this. Bigger than 2, less than 1, because 2 is bigger than 1. So I can write it, I cannot write it as between each other, and I cannot write it as and. So here it means when I'm solving bigger or equal than, so this is or. So you can write it in the end, or you can write it in the end of the final answer. If I want now to solve, this is the last example, absolute value less than or equal to 4, the same. What I need to do, it's either 4x minus 2 less than or equal to 4, either minus x plus 2, the opposite, less than or equal to 4. Then I solve again. 4x less than or equal to 6, x less than or equal to 3 over 2, x bigger or equal than minus half. So can I write it in between? Yes. So it means here it's and. So x is between. So and then you write the final answer, and don't overthink. Should I write and? Should I write or? In the end, when you finish, you write the final answer. So I want x to be bigger than minus half. You look at this one, and minus half is less than 3 over, so I can write it as interval between, and that's it. This is the final answer. That's it for this part. Later in the next video, we will start the partial fraction decomposition and the piecewise